Hi, and welcome to part 3 of the 6-part series looking at the feasibility of rainwater harvesting in arid environments. In this video, we will be looking at the AquaCrop model. So here's an outline of the remaining videos. Part 1, we went over an introduction. Part 2, looked at the rainwater harvesting equation. And part 3, which is this video, we will be looking at the AquaCrop model. Part 4, we'll look at the area that can be cultivated using the collected rainwater. Part 5, we'll look at the cost and maintenance of implementing a rainwater harvesting system. And in Part 6, I will be doing a run-through example. The AquaCrop model is a crop growth model developed by the Food and Agriculture Organization, or FAO. The AquaCrop model simulates the yield response of herbaceous crops to water when water is the limiting factor in the crop's production. So this is specifically important in arid environments as water is limited in these particular areas. The model also has a user-friendly interface that uses small number of explicit parameters and variables that can be determined using simple models, which include the climate information that we looked at in the last video, or video 2, as well as information you know about your own gardening or cultivating of crops. To access the AquaCrop model, you will have to download it to your computer. You can find it at www.fao.org/aquacrop. So here on this website, you'll be able to download the application. You'd want to download the standard AquaCrop program with user's interface and database version 7.0. Once you click on here, it should be downloaded to your computer. So once you click on it and it shows up in your downloads, you can go ahead and extract everything to your either your desktop or your documents. You can also find different resources on the AquaCrop model website. So they do have the workshops, so you can see who's using the application, as well as various resources, both in video tutorials or reference manuals, publications, and handbooks. I encourage anyone who is not familiar with the model to go through these tutorials or resources in order for you to become familiar with the model. It is also looks at the model in more in depth than I will be doing so in this video. This is a great one-stop shop for the different information you would need for you to run the model at its full potential. Once you have it downloaded, you can actually open the application. You will have the input requirements for the environment and crop information, as well as the simulation. For the environmental and crop information, you will need climate data, which is what we looked at and downloaded from Prism Climate Group in the previous video. You will need some information about the crop you want to cultivate, a little bit of the management used to cultivate these crops, and as well as the soil profile. As for the simulation part of the model, you will need to know from when you start sowing your crops to when you start harvesting. But other than that, it's pretty simple and straightforward. I will be going over the model overview, but just wanted to show you the information that you need to get this going. So for the climate, the required weather data, this is going to be the most important part of the model, because it's going to use this information to determine how much water is needed in order for you to cultivate a healthy crop. You will need the reference of evapotranspiration and transpiration, which is calculated in the model with using your rainfall depth and your minimum and maximum temperature, as well as the mean annual CO2, which is defaulted to the Mauna Loa Observatory. Once you open the application, it will prompt you to the first screen of the model. We will click Start. And again, just to kind of go over the environment and crop portion of the model, one of the biggest inputs is going to be climate. So if we click on climate, you can select or create a climate file. And this is what you're going to use in order for you to input the precipitation and temperature information that you downloaded in the previous video. I will click Create a Climate File. and then import and create. This is going to be for the file name for your climate file, which is going to include your rain information, your ETO, your temperature, and your CO2. So if I'm going to name it demo, and again, in the previous video, we did look at how to classify your precipitation years into a normal, dry, and wet year in order for you to get the 3 different volumes of water that can be collected during these classified precipitation years. So I will be doing it for the normal year. So now that we're going to look at rain, we'll create a new rain file. You can also upload a CSV or text file with that information and select it from the rain database. But to start off, this is going to be for the normal precipitation year. We will be inputting it monthly and not linking it to a specific year, since we did average out all our months for a normal precipitation year. And then we will set it from January to December. And then once you get this new window, this is where you're going to input the information you downloaded from Prism Climate Group. Note that this is in millimeters per month. So I believe in the previous video we used inches. So I encourage you all to go and do the conversion of the units or download the information from Prism in using the metric system. You will then put in the average precipitation for the months of January through December. So I had already created a file, which I named the demo normal, where I put in my precipitation information. Here it is when you plot it. And this makes sense, since in the Southwest, you do get most of your precipitation during the monsoon months of July through September. This is going to specify the ETO data once I'm running the AquaCrop model, meaning that it's going to take the temperature, both the minimum and maximum temperature. And again, a note that these are in Celsius, the temperature is in Celsius. So you want to make sure that the information you do input into the model is in the correct units. And again, the CO2 concentrations is going to get set to default atmospheric CO2 concentrations from 1902 to 2099. And this is the standard CO2 information based out of the Mauna Loa Observatory. Once you go back to the main menu, you'll see that my climate file is input into the climate portion of the model. So now we're going to look at the calendar. This is going to determine the period from which you are growing. So your growing season. This is going to be dependent on where you are located. So in the northwestern part of Arizona, a lot of the growing season starts in May and goes through September. So that is what I am choosing. Again, this is dependent on the area that you live in, depends on the length of the winter season and on the crop that you will be growing and simulating in this model. Back in the main menu, you will also have to choose the type of crop that you will be growing. Again, you can also use their default crops. So we go on to the crop button and select a /create crop file. Again, you can create your own crop file. This will, you will put in the information of what type of crop it is, if you're going to be sowing or transplanting, meaning if you're going to be growing it from seed. A lot of this information is available online or through your own personal expertise with growing. And then when you will be growing for this demo, I will be using one of the default crops that are provided to you in the crop database. So I will choose maize or corn. And a lot of these default crops have been calibrated for the northern hemisphere. And here you can look at the different information about this crop. So you can change information on the default crop, looking at the development of the growing period. You could put in this information yourself if you have it, or you can just go with what the default crop displays. So now back in the main menu, you can see that maize or corn is going to be my crop. Now we're going to look at the management. This is going to be in regards to irrigation. You do get different options. So we go to select and create irrigation file. You have these various options where you can determine the net irrigation of an irrigation water requirement. This is what we will be using, because what it does is it pulls information from that climate profile that you did earlier and then determines how much water is still needed in order for you to grow a healthy crop. You can also put in an irrigation schedule. So if you have certain days that you'll be irrigating, for instance, here in California during the drought, we are limited to how much irrigation we can actually use during specific times of the week and the month. So you could input that information. So if you're only irrigating once or twice a week or 3 times a week, that would be put in the schedule. And then you can also ask the model to generate an irrigation schedule for you. So in order for you to kind of know when, based off of the climatic patterns, when you will be required to input more water into your crops. For now, we will be doing the net irrigation water requirement to tell us how much we will be needing. So we're going to go ahead and create an irrigation file. And here we can just put a simple file name. You can decide if you want more or less water. So this here is the allowable root zone depletion. So this is how much the root zone can go without any water, and we have it at 50%. You can also increase that to maybe have it where the water cannot drop below the threshold leaf expansion, meaning that you have plenty of water to sustain a healthy crop. So you can also put it to 100%. This is where you are threatening the life of your crop because the stomatal closure will occur. For my project, I did put it at 20%, meaning that you did not want to stress out the plant. But again, you can turn it down to 50%, which is kind of like a standard. So once that's now your irrigation, this is going to determine that you want to get the information of how much water you're going to need in order to sustain a healthy crop. You can also put field management. This is kind of, you can create your own field management information. So information about the soil fertility, if you're using mulches, if you're preventing runoff. So if you are doing top irrigation or flood irrigation on your fields or your crops, that you're preventing the runoff to go away from that area. And of course, you can also look and input the weed management. So how much relative cover weeds are there, how your weed management is. So if it's moderate, that means that you do have some weeds. If it's perfect, of course, is all crops, no weeds, and then very poor, you have an excessive amount of weeds. As for the soil profile, you do have some default soil characteristics, but you can also create your own. Again, if you create your own, you would just put in your soil type. So you can specify if you have the thickness of your clay soil or your sandy soil or your loam. I will be choosing just a sandy loam, which is the type of soil that is used in northwestern Arizona. And this is based off of observation from my research project. And again, you do have all these different options. So I'll put sandy loam. And here, you can also still change the default information for your soil profile. So even though I chose sandy loam, I can determine the thickness of sandy loam. You can put in 4 meters, 3 meters. You are the expert and know your garden or your crop fields the best. So if I put 2 meters, you can also put the retention of file soil particles. This is just kind of like the fraction of the soil particles that can retain your water. You'll have also the stoniness and penetrability. You can also put information about the groundwater. So if you have a perch water table, then you could put that information on here. You can create a groundwater file and indicate how far the groundwater is to your crops or to your surface. In this arid environments, usually water tables are a lot lower than the roots of the plants can get to. So I will just be putting no shallow groundwater table. Now to look at the simulation aspect of the model, you can indicate when your simulation period is going to start. Again, it does reflect your calendar, which we input up here, but there are some other things you can change. Again, your simulation is linked to your growing period, but if you don't, you can take that off. You can change this. Let's say if you want to see what's happening in April or in October, then you would change these months to that. But I'm going to link it to my growing period. And here it kind of tells you like your climate information. So you've did put information since January all the way to December, and then your simulation and your crop are going to be, your planting period are going to be the same. And this will allow you to kind of determine, you can also look at the initial conditions. So this will allow you to input any information regarding the wetness of the soil. So for instance, if you have a really wet winter year, as we're having this year here in the Western US, our soils are saturated. A lot of them are. So we would be able to input that information. And you can create your own initial condition or use one from the database. Here you will be able to select or create a project file. This would then save all this information into one file. So if you were to come back and reuse the model next year or to change something, you can easily just select all this information that you've input. And then you can also put field data. So your field data, this is going to be your observations. So for instance, if you're doing this in successive years, you can put what you saw from the previous year. So you would put in your date and your observation. You can put your green canopy cover, the biomass, and then the soil water content. I will just be doing these very simple parameters and inputs. Once you're ready to run the application and once you've, again, put in your climate file, the information about your crop, your simulation period, and your net irrigation, you can go ahead and run the crop. You can put the simulation period. So you can go 10-day increments. So look at every 10 days, but since we are doing monthly, I'm just going to do it to the end of the simulation. You can see that it'll end on the 9th of September. Again, since it's not tied to a specific year, this isn't really, the year doesn't really matter, but I'll put 23. So we're in the 1900s. Evapotranspiration has also been calculated here at about 5 millimeters per day. This was calculated internally using the climate information that you input. So the CO2 information, the precipitation patterns, and the minimum and maximum temperature. And if you're familiar with evapotranspiration in arid environments, it's usually a lot higher than your average precipitation or the precipitation that falls during the day, which makes sense since this is definitely a lot higher than our rain patterns. So once we're ready, we're going to go ahead and click start. So now using all the information that we input into the model, you do get a production biomass and yield. And this yield is how much you can harvest at the end of the simulation period or of your growing season. And that's about 14.24 tons per hectare. Again, this is based off of your water, your climate and water balance. So if we click on this tab here, it'll give you your net irrigation requirement, and that's about 384.9 millimeters or about 151 inches of water that is needed or required in order for you to cultivate and harvest a yield of 14.24 tons per hectare. This is going to be the number we use in order to determine how much of an area can be cultivated solely using your rainwater that has been harvested off your roof. So this is one of the key outputs that we will be needing, as well as your yield. In your yield, you can do a dry yield or a fresh yield, but I think dry is the better way to go, just because that's the actual amount of crop that you can harvest. In the simulation, you can also look at various tabs and information. So this is the information we input. A little bit more about the production, so the growing period, and your as well as how much water evapotranspired per kilogram of crop. You can also look at the biomass, so actual produced and potential biomass, meaning how much you could have grown if you had no water stress, unlimited soil fertility, no soil salinity, and no weed infestation, which is what every single farmer or grower strives for. But of course, this is very, very perfect conditions, which are hard to attain sometimes, most of the time. You can also look at your numerical output. So this will display the information that you put in. So again, you can choose your time frame, day, 10-day, or month. We'll go with month. And this is going to show us the information that we put or that we simulated using the information we input. So we look at climate input data for the months of May through September. It'll show our precipitation, which again are pretty low in the northwestern Arizona. And then the ETO, which is going to be your standard, and your minimum, average, and maximum temperature, as well as your CO2 parts per million. So that concluded the look into the AquaCrop model. However, that was a very brief description of the model using very basic and default inputs and parameters. I encourage everyone to read more on the AquaCrop model if you have the time. There are plenty of resources on the FAO website that go into more depth of the capabilities of the model, which are immense. There's also peer-reviewed papers that kind of go over different case studies or what the models were used for. The video tutorials, again, will go into more detail of the model and its capabilities. So with that, here is an outline of our remaining videos, which the part 4 will look at the area that can be cultivated. Again, we're going to be using the net irrigation requirement that we simulated with the AquaCrop model, as well as the crop yield. Part 5 will look at the cost of maintenance, and then a quick and run through example for part 6. If you have any questions about this project or would like more information, please feel free to contact me at bnhernandez90@outlook.com or Dr. McCarthy and or Dr. Lutz at their respective emails. Thanks.